Hello and welcome everyone, and thank you for taking the time to join me today in the 9th edition of Grandstream Tech Talk. In today's session, we will go over the 4 top topics that were selected by the Grandstream audience in the last survey. Obviously, today we have Grandstream Access Points GWS 7600 series as the focus of our webinar. So regarding today's topics, we have roaming. So we're going to talk about the basics related to roaming. Then we're going to cover wireless mesh network and what you need to know about it. Then we're going to talk about Wi-Fi 6 and provide a comparison between Wi-Fi 6 and Wi-Fi 5. And the last topic for today is Wi-Fi coverage and signal optimization. We will have a few minutes to go over the questions and provide some answers. First, we're going to take a look at roaming. As you already know, roaming is the capability that allows wireless clients to seamlessly move between one AP coverage cell to another. And this takes place between APs that are within the same network name or SSID. So when you deploy multiple access points to provide roaming capability for wireless clients, there are many things to take into consideration to provide proper coverage and improve the wireless experience of the users. So an important thing to always remember is that the decision to roam between APs is made by the wireless client. In other words, it is the wireless client that decides when to roam to the next adjacent AP. One mechanism that is widely used by wireless clients to determine when they need to switch over is called RSSI, or the Received Signal Strength Indicator. And the RSSI metric is a relative value used to measure the signal strength or the signal quality in dBm. And while the wireless client moves across the Wi-Fi network, it continuously scans the wireless network for access points that have a better received signal. So when the wireless client hears a stronger signal from another access point, it will start the roaming process to connect to the new AP that has a stronger signal. Some applications and devices come with the option to set the scanning interval and the RSSI threshold. For example, if you are using the Grandstream Wi-Fi phone, WP820, these phones, they come with the option where you can enable scanning intervals based on the RSSI. So if RSSI is good, you can reduce the amount of scanning, but when the RSSI gets really weak, then you want to increase the scanning interval. And if you notice in the image, there is a clear correlation between RSSI value and the distance from the access point. So the closer you are to the access point, the better the signal quality. In addition, as the wireless client moves further from the access point, the data rate also decreases. In wireless technology, this is referred to as DRS, or dynamic rate switching, and it basically means that when the signal indicator grows weaker, the access point and the wireless client will switch to using a lower data rate. And this sometimes can affect the whole wireless network. For example, when you have multiple clients connected with a weak signal strength, this causes them to transmit at a lower rate. And eventually this will affect the clients that can transmit at higher rates, because the higher rate clients will have to wait for slower transmissions to finish before the wireless medium is available for them to transmit again. Remember that wireless communication uses half duplex medium, and only one client can transmit on the medium at any given time. And that is why a lower rate client can affect higher rate clients. So later in this presentation, I will cover a method called air fairness that is supposed to help with such a situation. So we explained the traditional method of using RSSI when making decisions about roaming. GWN access points can improve the roaming experience by enabling voice interprise. This feature significantly reduces the length of time required by the clients to switch from one access point to another access point during the roaming process. In normal circumstances, roaming using RSSI only can take between 300 milliseconds to 1 second to switch from one access point to another. And this is due to the fact that when a wireless client wants to move from the current AP to the target AP, it must go through the process of re-authentication and reassociation. And this can take more time in case 802.1x through Radius server is enabled. And to speed up the process of transitioning from the original AP to a target AP, there are 3 amendments that can be added to the GWN access point, and these are 802.11k, R, and V. So to explain how GWN Voice Enterprise feature can optimize the roaming experience of users, I will briefly explain what these amendments do and how they work together. So first we have 802.11k amendment, which allows the access point to provide the wireless client with a neighbor report. It is a message that the access point sends to the wireless client or wireless station. And this report includes the information about neighboring access points and the channels they are using. And this helps the client quickly decide where it should roam and what channel to use. So without 802.11k, the client would need to scan and probe all the channels to find the access point with the stronger AP. Next we have 802.11r amendment or standard, which uses fast transition to optimize the authentication process required when roaming from a current AP to a target AP. And essentially this amendment allows all the access points in the same ESS or network name to sync the authentication information so that a client does not need to perform the complete process of authentication. And we have 802.11v, which is used by access points to inform wireless clients of the adjacent access points that can provide better coverage and throughput. And one important thing to mention here is that for these functionalities to work, the wireless client needs to support these standards. So in case you have Voice Enterprise enabled on the GWN access points and you have some legacy devices that are connected to your GWN access points, these standards will not work because the client needs to support these standards as well. The other feature that is available on the Grandstream GWN access point is authentication using a Radius server. And the GWN access point, they support the what we call PMK caching, so that the client and the target access point can skip the process of authentication through Radius. So when you move from one access point, the access point will send the authentication or will synchronize the authentication that took place when you first joined the network, so that the second access point has the authentication required for the user to connect. So now let's take a look at the things you need to consider when using multiple access points to provide seamless roaming for wireless clients. And one of the most common mistakes many installers make when setting up a Wi-Fi network is putting all the access points in the same channel. So when you have multiple APs and clients transmitting over the same channel, that creates unnecessary medium contention overhead, which slows the performance of the whole Wi-Fi network. So when you deploy multiple adjacent APs to maximize the coverage, it is important that the overlapping channels are different. And as you can see in the example, each access point is using a different non-overlapping channel. So we have channels 36, 40, and 44. So in case you are using 2.4 gigahertz channels, we're looking at channel 1, 6, and 11. So we do not want to see all the access points using the same channel because that would create what we call co-channel interference. In addition, in multiple channel architecture, it is always recommended to have a coverage cell overlap between 10 or 15 to 20%. And this allows users to always have a strong signal from the access point. GWN access points also have the option to define the minimum RSSI required to connect to the AP. And the reason you want to do this is to avoid clients with weak RSSI to connect to the access point. Remember earlier I mentioned the lower the RSSI, the lower the data rates, and this affects higher speed devices because they have to wait for slow rate devices to finish transmitting before they can use the wireless medium again. So defining the minimum RSSI also helps with sticky clients, which are basically wireless clients that are stuck to the original access point, even if they are in a different coverage cell with a stronger signal. Just remember to use an acceptable RSSI value when configuring this option, and I would recommend between minus 75 to minus 80 dBm. Another setting that you want to adjust when deploying multiple access points is the power transmission. So when you have two access points next to each other and you see that there's a lot of interference, the GWN access point provides you with the option to reduce the transmission power. So you always want to run your survey so you can see the strength of the signal and the amount of the interference, as well as the SNR, or the signal noise ratio. There are so many applications that you can use on your computer or you can upload on your mobile device so you can scan the wireless network and get these values. Another thing also to remember is the difference between 5 GHz and 2.4 GHz. So if you are looking to cover an environment with high density, in other words, you have multiple wireless clients, you want to look at using 5 GHz instead of 2.4 GHz. But in case your main concern is to increase coverage of a large space, you're looking at 2.4 GHz. So 5 GHz works better with high density environments. And of course, when you have users that support the amendments that we explained earlier, you can enable enterprise voice on the access point. So the next topic for today is wireless mesh. So we're just going to cover the basics and explain how that works. So as you might know, wireless mesh network is an extension of the traditional wired network when using multiple access points connected through wireless links to areas where wired or Ethernet connection is not available. And the way that works, we use one of the access points for wired connection, and it will be assigned the role of a central AP or CAP. And the rest of the access points will be used as range extenders or RE. So in a wireless mesh, each RE or range extender will forward the received data in the direction of the central access point. In other words, all the wireless traffic will go through the central access point for routing. This is why it is really important that you do not include more than 5 APs in a wireless mesh network, because that would put more routing and processing pressure on the central access point. In fact, the number of REs attached to a CAP affects the throughput of users as well. So when more than the suggested number of REs are linked to a central access point and the wireless client accessing the network for high data usage, the CAP can easily become the bottleneck of the whole mesh network. Another thing, and depending on the location layout, there are 3 topology modes that can be used for wireless mesh network. There is chain mode, star mode, and hierarchical mode. So chain mode is used in networks requiring long transmission distance to cover more ground where Ethernet wired connection is not available. And the REs are connected in a daisy chain, and we do not recommend exceeding 3 REs in a chain mode. Star mode is usually used for hotspot coverage where the REs are directly connected to the central CAP, and we usually do not recommend using more than 4 REs connected to the CAP. Hierarchical mode, which is shown in this image, is composed of multiple branches, in general, the closer an RE is to the cap, the better performance a node device can have. We do not recommend having more than 2 RE branches under the cap and no more than 2 second level REs connected to each first level RE or range extender. So when talking about wireless mesh network, there are many advantages related to that and when using a mesh network. It is cost effective because there is no cost associated with running Ethernet cables, and it is easy to add access point to the mesh network, because if you are using GWN access point, the access point will dynamically configure them for the desired topology. However, wireless mesh networks come with downsides as well. Mesh network is not designed to solve wireless capacity issues. It is used to extend coverage where Ethernet wired is not available. Besides, it does not work well in high density environments because of the processing and routing loads that it put on the central access point. In terms of configuring mesh network on the GWN access point, you can visit the Grandstream YouTube channel and search for the video guide Grandstream Mesh Network. You can also go to the Grandstream website. There's a document that explains in details how to use and configure mesh network using the GWN access points. The third topic for today is Wi-Fi 6. So as you might know, Grandstream has released a new Wi-Fi 6 certified access points. We have GWN 7660 and GWN 7664. Both are Wi-Fi 6 certified and support all the technology included in Wi-Fi 6 standard due to the robust and high performance chipset that is included in the access points. So to briefly go through the specifications related to each model, so this GWN 7660, this one is a 2x2 access point. It can handle up to 256 clients and provide a coverage range of 175 meters and provide an aggregate throughput of 1.76 gigabits per second. Both of them, they come with a built-in controller that you can use to manage up to 50 other slave access points. For the GWN 7664, this is a 4x4 multi-user MIMO access point. In other words, it comes with 4 antennas for transmission and 4 antennas for reception and 4 spatial streams. It can provide wireless connection to up to 512 clients. The coverage range is the same as the GWN 7660, and it provides a high throughput of 3.55 gigabits per second. So in addition to Wi-Fi 6, they both support Wi-Fi 5 and the other legacy standards such as 802.11a, b, g, and n. And in general, Wi-Fi 6 is considered a substantial upgrade over Wi-Fi 5 and older standards. So the main focus of Wi-Fi 5 or 802.11ac was increased speed and higher data rate to meet the requirements of applications that use high data rate and to accommodate users in high density environments. However, there have been some drawbacks that prevented the legacy standards, together with 802.11ac, from achieving the advertised data rates. And this is generally due to the fact that Wi-Fi 5 and older standards have not been able to use the spatial spectrum or the frequency bandwidth more efficiently. So while the focus of 802.11ac and the previous standards was to increase data rates, the focus of Wi-Fi 6, as we're going to see in the upcoming slides, is to provide high efficiency. In other words, how to use the frequency bandwidth more efficiently. It's added new technologies to use wireless medium more efficiently. And in this slide, I will focus on 3 major enhancements in Wi-Fi 6 that are going to improve the use of wireless medium and eventually provide higher speed limits. So the first Wi-Fi 6 enhancement is multi-user MIMO for both upload and download. Because multi-user MIMO with Wi-Fi 5 or 802.11ac works only for download, which is the traffic from the access point to the wireless client. So now with wireless clients that support Wi-Fi 6, we can have multi-user MIMO for both upload and download. Of course, the wireless client needs to support Wi-Fi 6 for this to happen. For those who don't know what multi-user MIMO is, it is a functionality or technology that allows an access point to communicate with multiple wireless clients at the same time, which increases the wireless throughput because it reduces the wait time and the wireless medium contention. And with multi-user MIMO technology, the access point can simultaneously talk to up to 8 wireless clients. This is of course depending on the number of spatial streams or antennas supported by the access point. For example, we have GWN 7664 in this image, and it has 4 antennas and 4 spatial streams, which makes it able to use multi-user MIMO technology to simultaneously communicate with up to 4 wireless clients because it has 4 spatial streams. In addition to multi-user MIMO enhancement, Wi-Fi 6 added the OFDMA technology to maximize transmission efficiency. And the way that works, it takes a channel and divides it into up to 9 subchannels so that wireless clients can transmit simultaneously using multiple subchannels. If you look at the 2 images that compare OFDM, which is used in 802.11ac, to OFDMA included in Wi-Fi 6, you will notice that with OFDM, the wireless client will use the whole channel to transmit data, which results in a spectrum space that is not used. So even if the wireless client needs to send a small data, it will still use the whole channel, which will lead to a lot of portion of the channel that is not being used properly. So to address this shortcoming in OFDM, Wi-Fi 6 added multi-user OFDMA, which basically takes the used channel and splits it into multiple subchannels to allow multiple users to send and receive the same at the same time. So when multiple users are able to transmit simultaneously, we get increased speed and reduced wireless medium contention. Remember that these Wi-Fi 6 functionalities will only work with clients that support Wi-Fi 6. So because of the half-duplex nature of wireless medium, where only one node or device can transmit at any given time, Wi-Fi 6 has introduced a new functionality called BSS Coloring. And this functionality added a new physical header to identify each BSS, or basic service set. And basically a BSS is made of one access point and its associated wireless clients. So to give you an example why this is significantly helpful, when you have 2 access points transmitting over the same channel, even if they belong to different network environments and their BSS is overlapping as shown in the example, only one client or AP can use that channel at any given time. So with BSS coloring and the physical header that identifies each BSS, wireless users can now identify which BSS they belong to, and this way they can ignore the traffic that is sent by clients in another BSS, as shown in the second image. So generally speaking, BSS coloring is designed to reduce medium contention overhead. And without BSS coloring, co-channel interference would create more airtime consumption. In other words, if one access point is using the same channel, the other access point needs to wait for its turn. And with BSS coloring, wireless devices in the co-channel interference area can transmit on the same channel. So that's the benefit of BSS coloring in Wi-Fi 6. So this slide summarizes the main differences between Wi-Fi 6 and Wi-Fi 5, which is 802.11ac. So the main focus, as I mentioned, of 802.11ac was high throughput. Okay. However, with all the shortcomings in the standard, this standard was never able to achieve the advertised data rate. So even if it advertises a data rate of up to 3.5 gigabits, this is very hard to achieve even with a wide channel of 160 megahertz. And it operates only in the 5 gigahertz range. It uses multi-user MIMO technology for downlink or download only. And it uses a modulation scheme up to 256 QAM. It uses single user OFDM, which I just explained. That means each user will have to use the whole channel to send and receive. Wi-Fi 6 uses a guard interval of up to 800 and an OFDM symbol duration of 3.2 microsecond. Whereas Wi-Fi 6 main focus is to increase efficiency, how to use the wireless medium more efficiently. So when you use the wireless medium more efficiently, you eventually increase the data rate and the speed that an access point and the wireless clients can take advantage of. So with Wi-Fi 6, the data rates can go up to 9.6 gigabits using channels of 160 megahertz and 8 spatial stream. It's not special, it's a spatial streams. And it is backward compatible with both 2.4 and 5 gigahertz. It uses multi-user MIMO technology for both uplink and downlink, and a modulation scheme of up to 1024 QAM. Of course, it uses multi-user FDMA, which I consider as the biggest enhancement in Wi-Fi 6. It uses a guard interval of up to 3200. Just to explain what guard interval is, it is a period of time between symbols, and it works as a buffer for symbol delay. So as you know, wireless data usually takes different paths to reach its destination, and this results in data arriving out of order. So with Wi-Fi 6, we have increased the guard interval from 800 to 3200 and the OFDM symbol from 3.2 to 12.8 microseconds, which adds much broader multipath tolerance and reduces the contention overhead for the devices who want to use the same medium. That brings us to the last topic of today's webinar, which is about the best practices to improve Wi-Fi coverage and signal strength. This is a short list of things to consider when deploying GWN access points. So obviously the first thing to do when planning and designing a wireless network is to conduct a comprehensive site survey, because it would allow you to determine the numbers of access points needed and figure out the placement of each access point. Despite the fact that GWN access points support the option to dynamically assign channels, it is strongly recommended to manually assign non-overlapping channels to adjacent access points. You can use the same channel multiple times as long as their coverage cells are not overlapping. So as you might already know, 5 gigahertz band provides more non-overlapping channels than 2.4 gigahertz, which only has 3 non-overlapping channels. And we're talking about channels 1, 6, and 11. So in this example, we're using 4 5 gigahertz non-overlapping channels. So we are using 36, 40, 44, and 48. We assign them in a way to avoid co-channel interference, which is basically when you have 2 overlapping coverage cells sharing the same channel. Also accounts for 10 to 20% coverage cells overlapping, so that wireless clients can always have a good signal and good data rates. So far we have been focusing on RSSI metric. However, a good RSSI does not usually means you have a good, or you're going to have a good data rates. SNR, or signal to noise ratio, is another important indicator that needs to be evaluated across the wireless network. And the signal to noise ratio is the difference between the signal and the noise floor. So the larger the difference is, the better the signal quality will be. And there are many applications and software and apps also that you can install on your phone that can be used to measure the SNR in your network. It is really important to evaluate SNR because it tells us about the signal quality. You also want to reduce the total number of SSIDs in the network. So each additional SSID in the wireless network will bring a lot of air, what we call air interface overhead. So every time you enable an SSID, it will start broadcasting its beacon frames and management frames. And just these two types of frames can easily consume 3% of the data rate available. Next, we have adjust the size of the coverage cell as needed. So if you look at the image, if you look at channel 48, you will see that the size of this channel is kind of smaller because we want it to be smaller than the other ones, because when you make the radio power high, the signal propagates over a long distance, and sometimes that could create a lot of interference. So we just want the radio signal to propagate to cover the area that we need with the access points. Also remember to enable minimum RSSI as needed. As I mentioned earlier, this is going to help with sticky clients who remain connected to the original access point, even if they are in an area where there's another access point that can actually provide them with a better signal. The other option that you can enable if needed is air fairness. The default behavior of the access point is that they're going to allow each client to send specific amount of data. And when you have a client that is really slow and a client that has high speed rate, both of them, they're going to be competing over the same medium. So the client that has higher speed will have to wait for the slow rate client to send all the data that it needs to send based on the algorithm that the access point is using. To avoid such situations, so that you can always allow the clients with high speed rates to always transmit more, you can enable the air fairness. And basically when you enable that option, the access point will provide each client with specific amount of time to send their data. So if there is a client that is slow, it's going to send small data during that time frame to allow the other clients to send their data. So that brings us to the end of today's webinar. Let me see if we have any questions. And I see we have 1, 2, 3 questions. And the first question is, where do you enable Wi-Fi 6 on GWN access points? Actually, Wi-Fi 6 is enabled by default. Let me get to the web interface of the GWN access point. All right. Actually, we need to go under configuration. So if we select this access point, you will see that it is enabled by default, which is AAX. So AAX is Wi-Fi 6. So it is enabled by default for 2.4 gigahertz and 5 gigahertz. So in case you want to disable Wi-Fi 6 for 2.4 gigahertz, you simply check this option. So it is enabled. The access point will detect every time it sees a client that supports Wi-Fi 6, they're going to start communicating using the Wi-Fi 6 functionalities. The next question is, where do you enable minimum RSSI? I think it is somewhere here too. Yeah, it's right here. So enable minimum RSSI. So if you enable that one, you can actually set a value. So for example, if I want it to be minus 80, so when you put the value here, when the access point sees that there is a client with an RSSI that is, let's say, minus 85, the access point will not provide that client with wireless connection. So you always want to implement this carefully. So if you want to set a value, just make sure that the boundary of the coverage cell actually covers that value that you have here. Another question is, has GWN 7664 been released yet? How come I don't see it on the Grandstream website? I believe this model has been released this week. We can go to the Grandstream website. So if we go to networking solutions, Wi-Fi access point. Yeah, it is not here. I believe it's going to be released sometime this week or next week. So probably if you check next week, you're going to see the GWN 7664 available on the Grandstream website. All right, so I think we reached the end of today's webinar. Again, thanks everyone for taking the time to join me in today's Grandstream Tech Talk. Have a good day, and I hope to see you in the next episode.